right, so for this first one, we have that the 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 decathlon is a competition where athletes compete in 10 events. Two of those events are long jump and high jump. In both events, a greater distance means a better ranking. The table shows the results for these two events at the World Championships. So, for example, Germany for the long jump in its ranking is number one. Okay, and number one in this sense, because as it says here that a greater distance means a better ranking, that means that here they're first place. And as we can see, the biggest number for long jump is 7.64 meters. Do you see any number bigger than 7.64 meters in this column? I don't. It's the biggest one. So that means Germany is first. What is the second highest? Well, it's France with 7.52. So here they would be second. And as you can see, long jump ranking is in order. Okay, it's in order. It's nice and pretty. It's friendly. Okay. You're going to see in a second that for the high jump rank, it's not in order and there's some things we have to do. But let's go piece by piece. Let's see what happens. They tell us that Spearman's rank correlation coefficient, what the hell is that, is used to determine if there is a linear correlation, what the hell is that, between an athlete's ranking in long jump and their ranking in high jump. Alright guys, so before we jump into parts A, B, and C, which are honest, it's not that hard, but you do need to understand what is going on. Okay, so there's a lot of buzzwords here that some of you may not be so familiar with, so let's go piece by piece. A lot of this talks about correlation, okay? When we talk about correlation, the intuitive way to understand it is like, if X increases, how does Y increase? Okay? So, in this case, what they're telling us is if their score in long jump is, I don't know, around here, a very strong correlation means that the score in high jump is like the same level. See? So if it has a good score in long jump, then they have a good score in high jump. That would be a strong correlation. A correlation that's a little weaker might say, okay, they have a very good score in long jump, but not so good in high jump. See? And so this would also be a linear correlation. As you can see, I'm also drawing a line, but the slope is a little bit less. If the slope of this one is, I don't know, 1/2, then the slope of the one I just drew was around 1, okay? All right, guys, just forget about slope for a moment. I know that can confuse a little bit, but the idea is if there is a strong correlation between long jump and high jump, it means that the better you are at long jump, also the better you're going to be at high jump, okay? Maybe another correlation that makes sense is like, I don't know, if you're good at chess, then you're also going to be good at whatever, like other board games. See? And that might make sense because chess takes a lot of strategy and thinking and stuff like that. So if you're good at chess, you're going to be good at most other board games. If you're good at Counter-Strike, then you're good at Call of Duty. If you're good at League of Legends, then you're good at Dota, whatever. Like I don't know, dude. Okay, you guys get the idea. So that is the intuition for correlation. Okay, so if there's a strong correlation, then like one thing sort of implies the other. Keep in mind that this is different than causality, okay? When we talk about causality, you need strong evidence to support it. You can have something with a very strong correlation, but a strong correlation does not mean that you have strong causality, okay? All right, whatever. So that's correlation in a nutshell. And when they talk about Spearman's rank correlation coefficient, the correlation coefficient is a number that tells you how strong that correlation is. So remember how I said just now that we had slopes, right? The correlation coefficient is a little bit like that slope. And so the strongest slope you can get is a slope of 1, okay? And so if your slope of 1, or your R that we're about to see, is equal to 1, then that's a very strong correlation coefficient. If it's less than 1, you still have correlation, but it's a little weaker, okay? So that's what we're trying to do, okay? That's the correlation coefficient. And what Spearman does is just this guy that said, yo, for finding the correlation, we're going to be ranking our stuff. See, so that's why we have a column for rank for long jump and a column for rank for high jump. So we're going to go ahead and rank long jump, rank high jump, put them next to each other, and see if there's a correlation. Okay? Between which two things? Long jump and high jump. Okay? So that's a little bit of the context. I think it's very important just to understand what we're doing. And you're going to see that the method or the process for solving this is actually very, very fast. Okay? So for part A, we need to complete the table to show the athletes' rankings in high jump. So as we can see, high jump is empty. Now, because it's a ranking, it works the same as the one right next to it. Let's remember, Germany is first because it has the highest value for long jump. France is second because it has the second highest value for long jump. Now, let's focus only on high jump. So for example, Germany for a high jump has 2.11 meters. Is there any country that is higher than 2.11 meters? I don't see any. So Germany, we're going to go ahead and say is first. Okay, so we're going to put number 1 here. Which one is the second highest? Conveniently, it's actually France right below. See? But now is when things start to get really, really weird. Estonia. Estonia, is it third? It's not third. See? Actually, which one is third? So we did 211, 208. What's next? I see a 205. It's probably this one. Do we see anything higher than 205? No. So we're going to say that the third rank is right here. All right, what about the fourth rank? So below 205, we have 202, 202, and I don't see anything else. All right, guys, and here is something interesting that occurs, okay? Because Canada and Ukraine are tied for fourth place, technically they both share fourth place, see? But because we're talking about Spearman's rank correlation coefficient, the key thing is that the ranking needs to be aligned. Like the first with first, the second with second, the third with whatever third is for high rank, the fourth with whatever fourth is for high rank. See what I mean? And so here you actually can't have them tie for fourth because in that sense it wouldn't like fit in. See? So intuitively, whenever they tie, in this case they're tying for fourth, you can think about it like this one's fourth and this one's fifth. But they're so close to each other that they might as well both be what's in between. So if we have fourth and fifth here, what's in between? Well, you have 4 plus 5 divided by 2. That's what's in between. 9 divided by 2, 4.5. That's what's in between. See? So because they're tying, you're actually going to put 4.5 and 4.5. See? Why 4 and not 5? Because it's in between. See, it's the calculation that it did. So whenever they tie, you're just going to take like a simple average, and that's that. See? And from here on out, it's a lot more forward. So there we have this one, this one, this one. What's below 2.02? Below 2.02, we have 1.99. So this would be, actually, do I have anything else? Hold up. 1.99. Yeah, so this would be sixth. And I know some of you right now are thinking, yo, what the hell are you doing? Point is, this one is technically like 4 or 5. And this one is also technically 4 or 5. Okay? And so we were forced to skip to the sixth. Okay? That's like the idea. I know that part's a little weird, but it all has to do with the fact that Canada and Ukraine tie. See? So you can think about the fourth and the fifth one already getting checked off. Okay? All right, cool. So that's why Grenada, I don't know if I'm saying that right. Sorry, it's sixth. What's seventh? What's below 1.99? This guy here, Japan. Number 8 would have to be this guy here, Algeria. Cool, cool, cool. Then we have Austria and finally Estonia, ¿cierto? All right. So that is literally part A. See, it's not that hard. The biggest thing you have to keep in mind is when they tie, what do? You find a simple average between both. Okay, that's the only way they can like sort of catch you. And be careful that Granada ended up being number 6. Okay, we didn't put number 5 for Granada. We put number 6 because technically the fourth and the fifth were already sort of like checked off. Okay. All right, whatever. For part B, we need to find the value of the Spearman's rank correlation coefficient, RS. So, Of course, we need the calculator here. See? And so something that I talk a lot about in my videos is that a big part of this test, okay, or the IB in general for the math, is really just being familiar with your calculator, okay, being familiar with the formula booklet and stuff like that. Guys, the day of the test, you're gonna walk in, you're gonna have this guy right here, your calculator, you're gonna have your big brain, you're gonna have your formula booklet, you're gonna have probably like 2 hours of sleep and a lot of motivation to do well in this test, okay, and your brain. I don't know if I already mentioned that, but whatever. Pen and pencil, all that stuff. See? So, of all this stuff you're gonna be walking in with, you gotta feel good about it. Okay, you gotta know what's in it. Okay, and I'm not saying you have to know it by heart, but you do have to know where stuff is, sort of. Okay. For example, these are tools that you have. Okay, so imagine you're at home and you have a broken window. Okay, and you need a hammer to nail it, cierto? And you don't know where the hammer is in your house, but you know what room it's in. Okay? This is no different. We need to use Spearman's rank correlation coefficient. And I'm not saying, ooh, where is it exactly? But I am telling you, okay, do you know which room to find it in? Okay? Do you know if it's distribution here in blue, or if it's the stat button, or if it's math button, like which one? Okay, that's that is the sort of stuff that you need to know. Okay? So I'm just gonna say it right away, but for this case, because we are calculating something, okay, you're gonna go stat, here you have calc and test. Okay? In this case, Spearman's rank correlation coefficient is technically like a linear regression. Okay, so here you have a lot of linear regressions, but none of these give you the Spearman's rank correlation coefficient. Okay, here you do have a line reg, but it doesn't give you Spearman's rank correlation. For Spearman's, you actually go to test, and it's all the way down in this thing called line reg test. Okay, so if you want your R value, you gotta do line reg test. So as you can see, I have two line reg tests. See, I have line reg int and line reg t test. Okay, the int, as we can see, asks for a C level and stuff like that. It's a little weird. You're probably never gonna use it. Forget about it. Okay, so now you know. For line reg test, you just use the other one. See, so if you see the thing that says C level, you're in the wrong one. Probably. Okay, I've never have had to use it for any of these tests. So I go over here, it asks for a bunch of stuff. Okay, and I know some of you might be thinking, yo, what the hell? What's going on? Take it easy. I got you. See? So on the one hand, it asks for X list. See? Basically, it's going to be your first list. So in this context, we're going to say that this is L1, okay, and this is L2. So that means my X list is going to be my long jump, and my high jump is going to be L2. That's it. When it says frequency here, okay, intuitively, that has to do with how much, like, if this is a cumulative if this is a frequency table. Okay, so for example, if I put frequency 2, I might be saying like, oh, and this one appears twice. See, stuff like that. Okay, for this context, it really doesn't matter. And for Spearman's high rank correlation coefficient, you're pretty much always going to leave it on 1. Over here, as you can see, it's a p-value. Okay, it's for calculating probabilities, how likely it is. Like, that's for helping with causality, as I mentioned earlier. See, right now we're only focused on correlation, so you can actually put any of these three, and it doesn't matter because it's not going to change the value that we're looking for, which is just the correlation. See, so I'm just going to put the one in the middle. Doesn't matter. Okay, it really doesn't matter. Yeah, because I need to put the X list and the Y list, where do I put it? So I go to stat, edit. Okay, stat, edit. Here's my list 1, here's my list 2. Make sure you clear it out. A quick way to clear it out is go up, press clear, press enter. Go to the other one, press clear, press enter. Bada bim, bada boom. So list 1, I know it's not the most exciting thing in the world, but we are doing math, so I don't know how excited you might be, at least for some of you. You're just going to put the first list, which is from 1 to 10. Cool. The second one is a little more tricky. So I put 1, I put 2, here I put 10, here I put 4.5, 3, 4.5, 8, 9, 6, and 7. And here's an important point that I didn't mention earlier. So remember how this is Spearman's rank correlation coefficient? The cool thing about it is that one of your lists is completely ranked, like from 1 to 10, and the other one is a little more all over the place. See? And so you're going to have a strong R value if your L1 is similar to your L2. If they're very different, then your R value is not going to be as big. So for example, the first and the second, as we can see here, are the same. Okay, that's going to be a good R value. The second ones are also the same. That's going to be a good R value. But for the third one, there's already a very big disparity from third to 10th. Okay, that's a massive difference. My R value is going to be affected. For 4 and 4.5, similar enough, not the same. For 5 and 3, similar enough, not the same. And you can sort of say the same about the rest. Okay? Except for 9 and 6 and 10 and 7, that's a pretty big disparity. Okay? So I'm going to end up with a solid R value. I wouldn't say it's going to be an amazing R value. So, anyways, I go to stat, I go to test, I go to line reg, bada bim, bada boom, here it is, kapow. See? I never use the interval one or the int. I use the test one. X1, sorry, X list L1, Y list L2, frequency 1, you're pretty much never going to change that. This is probably anything you don't care about. Reg EQ is if you ever want to graph your thing and you want to put it in your Y equals, you need to put like Y1, Y2 in here, okay? We're never going to use it, so we don't care. Go ahead and press calculate. A bunch of stuff shows up. So as you can see, the first like 4 or 5 things have to do with the probability thing I was talking about, like the causality, the test we were running, okay? Because you can run a test like, okay, how similar are these? Like to what probability, to what significance level, all that stuff. Okay, that's here, yeah? And depending on whether you ask, not equal to 0, less than 0, greater than 0, you get different results, okay? But we we don't give a shit. We don't give a flying fuck because all we're going for is scrolling all the way down and getting that R value. See? So R value for part B is going to be R equals 0.541 with 3 significant figures. See? How do I know it's 3 significant figures? Because for 3 significant figures, you go 1, 2, 3. You see if we round it up or down, it stays the same. So 3 significant figures is like that. Okay? All right, cool. And it really, really doesn't matter what you put, okay? You can put, oh, what if p is not equal to 0? You're going to see that the values up here, like the first 4 values are going to change. See, remember that my p value before was like 9, 6 or something? Well, now it's it's 0.1, okay? But my r value, which is what we really care about, doesn't change. And that's what really matters for us. So whatever, okay? That's part B. Finally, part C, very straightforward. We have that the following guide is used by the coach to determine the strength of correlation. Strength of correlation. So remember, you have this correlation, right? We have long jump and high jump, okay? A very strong correlation is if it's a linear relationship, see? Like with a slope equal to 1, right? So this would be a strong correlation, right? They have the same slope. That's very strong. It might be a little weaker if the slope goes something like this, okay? Because as long jump improves, high jump also improves, but not as much. Okay, that's the whole idea, not as much. So let's see what's going on here. Basically, if your R value is between 0 and 0.199, it is very weak. If your R value is between 0.2 and 0.399, it's considered weak. So in this case, because my R value is of 0.541, what does it qualify as, you guys? It qualifies as moderate. Okay, 0.541 goes into the moderate category. And still, for part C, we need to state the strength of the correlation between the rankings as indicated by the table and interpret this in the context of the question. So, there's a lot of different ways to answer this, but immediately you have to say the correlation is moderate. And I guess you can give a short explanation because 0.541 is between 0.400, and 0.599. So just with that, you already have 1 point, okay? For the second point, there's a lot of different ways to put it, but I'm just going to put what the answer key says. Okay, the answer key says, as long jump ranking increases, high jump ranking will likely increase, okay? So that's going to be for your second point, and you're good to go. If you don't like how the answer key puts it, you can put something that's very, very similar, okay? And so what I would do, just because for me it's more intuitive, I would say as long jump ranking increases, high jump ranking increases moderately. See? I don't know how the hell to say that. Moderately. Moderately. I think it's that. Moderately. Alright, whatever. Who gives a shit? See? That is part C. Alright? So guys, as you can see, if you take this video and eliminate all the intuitive concept explanation part, you do this right away, dude. Okay? It's a quick problem. It's quick points. But if you show up and you read Spearman's rank correlation coefficient and you have no idea what the fuck it's talking about, dude, you're gonna miss on 6 easy points. Okay? Guys, for a lot of this, just knowing a little bit gets you a long way. Okay? For example, I think it's in this test, but later on it talks about something that's the normal to the curve. There's a lot of sort of buzzwords and vocab words that if you don't know, you're just like, you're fucked, okay? The normal to the curve is like, it's the perpendicular to the tangent, okay? I'm not gonna get into it. I have videos on it. But the idea I'm trying to tell you guys is that there's a lot of vocab words that if you don't know, you can't even get started on the exercise. Okay? You need to know the intuition of each exercise. All right? And I'm not saying you have to know it by heart. I'm not saying you have to know like everything like perfectly mathematically, blah, blah, blah. No. But I am saying you gotta understand the intuition. Okay? If it talks about correlation, it's gotta ring a bell. Okay, if it's talk about Spearman's rank, you gotta think, that's a tool I have in my toolkit. I know which room it's in, but I just gotta find it. So you're gonna be in the day of the test, you're gonna be looking at tests, trying to find it, and eventually you find something that says line reg. Right. It's a line reg because we're going for a correlation. Kapow! See what I mean? So it's that kind of stuff that really helps. Okay, just knowing the intuition, knowing the methodology for the exercise is key. Ladies and gentlemen, that is the first one. I hope it helped.